So homework question number 5. Let's see. So let me write it at 2 p.m. Well, again, the time will vary from one student to another, but at 2 p.m. ship A is 150 kilometers west of ship B. Okay. Ship A is sailing east at 35 kilometers per hour, and ship B is sailing north at 25. Okay, the question is how fast is the distance between the ships? How fast is the distance between the ships at changing at 6 p.m.? Again, this is a case where we need to draw a little sketch and figure this out. So let's see, we have one ship that's sailing east and position west, and the other one is 2 east but sailing north. Okay, so let's say this is, let's start with ship A. So this is ship A, and it's essentially sailing east. So east is in this direction. And we might as well position the coordinate system right there. Okay? So I'm going to, for matter of convenience, I'm going to position my coordinate system right here. Okay? So this is X and this is Y. And Y is the north as well, and X is the east. Okay? Again, a matter of convenience. So this ship is sailing west. The distance between the two ships, where this is B, is 150 kilometers. So this distance is 150. It's given. Now, this one is moving in this direction. So this one has dx dt, and it's positive, and it's 35 kilometers per hour. Okay? So we have this direction. And now, this distance is true at 2 p.m. We need to keep that in mind. The other ship B is sailing north, so it's heading this way, right? And the speed or the velocity will be dy dt, and it's positive because we're going up. So both velocities are positive, and this will be 25 kilometers per hour. And what we want to know is what happened at 6 p.m. Well, at 6 p.m., which is 4 hours away, the boats or the ships will be, ship A will be right here, and ship B will be right here. So if this is A sub 0 and B sub 0, the initial position, the new position will be A and B, and we have this triangle right there. Okay? So what are the legs of this triangle? Well, this will be 100 miles, 4 times 25, and this will be 150 minus 4 times 35. Well, 4 times 35 is 140. So actually, I should have drawn it better. So let me do this. Let me use a whiteout here. I didn't realize that the east-west leg is so narrow, so small, so short, I should say. I need this kind of whiteout that dries instantaneously. So let's do this. So this will be B, the new B, and this distance right here is 10 miles. Okay? Well, the overall distance. So this ship traveled 104 times 35, which is 140 miles. Okay? I'm sorry, this is ship A. You can tell that this is A, right? So the new position. So we need to work on this. And again, this is the distance. And the rest of the problem now is exactly the same what we did before. Okay? So the setup of the problem is the one that you can jump right there into this conclusion. Okay? There is no difference, so you can use the example 4. Was it example 4? Use example 4 as a starting point. And say that dt will be 1 over d times x dx dt plus y dy dt, because nothing is changed here. Okay? The only values are x equal, okay, x will be this one. Okay? Here we need to be really careful, because the way I position the coordinate system, now we need to use a little bit common sense to overcome. X is the length of this leg, so we know that it will be 10 kilometers, not miles, but kilometers. Okay? But what is the x dt? Is it positive or negative? It's negative because, again, the distance, the way we wrote it is decreasing, so it will be negative 35 kilometers per hour. Okay? And again, why is that? Because this quantity, which we call the x, is really measured from here to the left. So it's negative, the velocity. dy, y is, with y we have no problem. Y is 100 kilometers, and dy dt is 25 kilometers per hour. And I'll stop here because the rest is exactly the same thing. So this is enough information.